A few of you have asked about the completion of labs for Module 2. This video is an attempt to briefly introduce you to the math module and to explain how to complete the third lab of Module 2. Python has built-in functions that are readily available for you to use directly on your program, like print and input functions. Some other commonly used built-in functions are int, float, and round. Int converts its argument to a whole number. There is no rounding in it. I'll give you an example. So in this case, we want to convert 69.85 to an int. We want to convert a string which has the number 896. We want to convert this to an int. So if I run this, all right, so let's see. You see what happens here? So you have 67 and 896, which is what we have here. All right. So a float converts its argument to a floating point real number. So let's take examples of those. So this is using float. So if I have float, so let's say float 7. So all right, so we want to convert the integer 7 to a float. We want to convert the string. This is a string which is a real which is in this case a float number. So it's going to convert that string to a float. And let's take another one here. Let's say we have 78, which is a string. It's going to convert that to a float. And then we take another one, so 89.65. This is already a float, but it doesn't really matter. It's going to just convert it to a float, okay? So it will still be a float. It will still be the same number that you have there. So if we run this, we see here from the result, you can see 7 is converted to a float. You can see the dot 7.0. Then you have 7.85, which is a string that was converted to a float. 78 was a string. It converted 78 string to 78.0. And then, of course, this one remains the same. Okay. The next one here is str. Str it converts its argument to a string. Whatever argument you give it, it will convert it to a string. So let's try str. Let's say 67. So it's going to convert 67 to a string. Str. All right, let's say we have 789.89. All right, so it's going to convert that to a string. So let's run this. So you see here I have an integer and then I have a float. And I'm passing it to this function str. Is going to convert those values to strings. So we run this. Again, you see here, although it's not really showing that it's a string, but it's actually a string. But you can tell, you can check to see if it's actually a string once it's converted. All right. The next here is boolean. Bool will convert its argument to a boolean, which is either a true or a false. Okay, so let's take bool. So if I have a bool of 0, what would that be? All right. If I want to find the bool of -7, what would be the bool of -7? So what about bool of 8? And what about bool of, say, empty string? What about bool of, say, hello? All right. So we have So this bool is going to convert whatever the argument is to either a true or a false. So let's run this. All right. So when we run this, you see here 0 is false. Then we have here -7 is true, and 8 is true, empty string is false, and the hello is true in this case. So the next function I want to touch on here is round. So Python has a built-in function called round. So round with rounds is first argument to the number of decimal places specified by the second argument. So let me give you examples. So let's say we have round, okay, of 899 point, let's say 76776, say, right? And then we want to convert it to we want to round it up to 2 decimal places. Okay, so we will specify 2 here, right? And then we'll do the same here. Let's say we want to round. Let's say the number is 67.121156. Let's say. And then the argument we're going to specify, we're going to round this to 3 decimal places. So we'll specify 2. Okay, we close this. When we run this program, let us see the result that we get. You see? So we see here that this 8899.76777 is rounded to 899.77, and then you see here 67.121156 is rounded into 3 decimal places, and then we will have 67.121. So this round function here will round to the number of decimal places that you specify in the second argument. There are many other functions that are packaged with Python installation. For simplicity, we will regard a package as a module or a library. Okay. For now, let us just say that a module or a library consists of function definitions, right? And to use any one of such library functions, we must include the module in our program. This is accomplished with an import statement. So if we want to import a module that came with Python installation, we will use the import statement. So the import statement will look like this. I'm going to comment it out. It will be import and then a module. So the module here, this will be the module name. So we're going to include this whole thing in our program. All right. So we have module, we will have import, and then the module name. This is the module name, right? So the module name goes here where I highlighted. So what will happen is when we type this in our program, if the module exists, if the module is included in the installation that came with Python, what will happen is at the time of execution of the program, that module will be loaded into the program before it executes. Okay, so this is very important. So what you're doing here is you have to include the module. Now, like I said, the module comes with function definition. So to use any of the library function that is defined in that module, we have to know the name. We have to know the type of input or argument that the function takes. Just like we did with print, just like we did with bool, int, float, and all of those things. All right. So the way we will do that, if we know the name of the function, so to call that function, we will do module, which the module name goes in there, and then the function name goes in here, and then the arguments, whatever argument that the function accepts. So the name of the function goes in here. The module goes in here, all right, and then the argument, if there are any arguments, okay. Notice that we're using a dot here, okay. This dot signifies that the function is defined in the module. There are many Python modules, right? The one required for Module 2 Lab is the math module, so which I'm going to go over. So the one that that is required for the assignment here is the math module, and the name of the module is math. Okay, so we'll call it math module, right? So the math modules has many mathematical operations. Okay, like square root, like sine, cosine. Additionally, it had definition for constants like pi, pi, definition. So examples of operations that are in these math modules are square root, right? Anything that would do square root, we would describe that. Sine, cosine, and then it also includes constant like pi or natural exponent. Okay, natural exponent e. I'm sure you are familiar with that. So e. All right. So we're going to demonstrate how to use this math module. So to use the math module, the first thing we will do is to import it, right? So here we're going to import the math module. We're going to say import math. Okay, so to our program. So we import the math module to our program. Now we need to know the names of the function we want to use in our program. So I'm going to give you some examples. Okay. So like I said, pi and other natural exponent are defined. Let's just try those, right? Let's find what those values are, in the math module. So the way we will do it, let's say we will display math.py. Okay. All right. If we type math.py, so that is going to display for us what the value of pi is, the way it is defined in the math module. The same thing with exponent. So let's run this code now. All right. So it's trying to run. Oh, I didn't run it. All right. So we see here, you can see the value of pi, the way it's implemented in the math module. You can see the value of natural exponent, the way it is implemented in that math module. All right. Now, if we know other functions that are used in the math module, we can try it. For example, there are several function names. Okay, there are several function names. So some of the names I'm going to give to you. So for example, SQRT is for square root, sin, SIN is for sine, COS is for cosine, and so many others, right? And so many others. So things like floor is implemented here, and so on. All right. So to use the square root in a math module, what do? I would just call square root, right? So let's try that. So we have math dot square root. Okay, math dot square root. Let's say 5.89. Okay, so I want to find the square root of 5.89. So if I run this, let's put here. Okay, the square root of 5.89 equals to, again, we're going to use the placeholder since now I'm using the f string. So all right, so the square root of that is going to be displayed there. So if I run this code, all right, we see here that the square root is displayed. You can see the square root of 5.89 is given by that, right? Yes. Okay. So now I can do all kind of stuff with this, right? So I can do something like math sine. I want to find the sine of the square root of 0.2666. Okay, I just came up with that. I mean, there's nothing really important about that number. I just came up with that number. So if I run this, it also execute the code. All right. If I execute the code, you can see it gives me the value of this. It evaluates this whole thing here, and it gives me this value right here. All right. All right. So what if I define a variable? So let's say I define a variable s is equal to 3.89, right? And then y is the square root of x. So how do I do that? So I will do math dot square root of x, and I'm going to display x and y. So I will say print x and y, right? So this is going to display x, and it's going to display the square root of x. Does that make sense? Okay. All right, so if I run this, you see it's going to give me the two values. So this is x, and that is square root of x. Does that make sense? All right, now, what we're going to do is complete you can see now with this information, this module seems relatively straightforward, right? So the first thing you need to do is enter these values, take, from the input, right? And once you have entered those values from the input, you will use this formula to compute the distance, right? Okay, any questions? So I can copy this distance. Let's copy this distance over here, although it's not going to show. So that is what we want to display. So this is the distance we want to compute. All right. Of course, we don't need this. So we're going to use math dot square root, right? That's what we're asked to do, right? So this will be x1 minus x2, but then this is going to be raised to power 2. So we do exponent to 2. All right. And then this is also going to raise to power 2. We do exponent raised to power 2. I guess that's it, except that I think that's it. So what we need now is to obtain the value s1, okay, value s2. The way they did it here, I think, is s1 y1, right? y1, okay, and then s2 y2, right? y2. Okay, so this will be input. Now we want this input to be a float, so we're gonna say float. We're gonna convert whatever is entered to a float, right? And then we're gonna do the same thing here. We're gonna convert whatever is entered to a float, because input here will return a string. The input function always returns, returns a string. All right. So in this case here, we will have float, just like we had before. Okay. And lastly here, we have float input. All right, so here, this is an error here. Just want to correct that. Okay, so we're done. So that would give it the distance. So when we have computed the distance, what do? We will just print, and then we're going to use the rand function, since I taught you the rand function. That's 2 decimal places. That is what the problem requires. So what I'm going to do is to comment this out, because we don't want this to be part of the module. So I just use this to explain the module to you. So I'm going to comment this out. So this is all commented out. So we have the input. We import the module, and then we have the input We input all the values, and what do? We compute the distance using the distance formula that is provided. Okay, and then we display it by doing rounding. So if I submit this for grading, hopefully it should be okay. Let's see what happens. There's an error. So let's see where the error. There's a matching value is missing there. So let's go and correct that. So you can see here that we're supposed to include another open parenthesis here. So this is for that, this is for that, this is for that, and then the last one. So I'm going to do it again. Let's see an error. Let's see what happens. So so now we have it's displaying 5. I think there are other things that I should have commented out. Let's see why it's not commenting them out. Some of the other stuff that I've been displaying here, we don't want them, right? Let's see what happened. Here we go. So we're supposed to comment all of these out, right? We didn't. All right. So let's try one more time. Okay, there we go. All right, so everything is working nicely. So the code that is required for this assignment is just this few codes. So I can move this up so that it will not, or I can just delete it completely so that it will not. So I can delete this completely. All right, and I can also delete the one above it. Okay, if I delete the one above it, let's see here. All right, so this is all that the code, this is all you have to write for this assignment. It's actually a short one. All right, that is the end of this video, guys. Take care.